everybody. So welcome. We are in week 3 and you didn't have school on Monday, so hopefully you got to sleep in a little bit more. And anyway, so we are discussing section 4.3 in the pink packet. I am on page 58 and we're going to go over something called the rational root theorem. And we use this when we can't factor. So in our past chapter when we graphed with parabolas and we couldn't factor, we had a backup. We could do the quadratic formula where we had a song. And there's a song for this one as well, which I will do for you in person. I didn't make it up, but it is a unique song. Anyway, so we need to think about, well, what if we can't factor? Because right now I've been giving you problems that can factor. So what I want to do is I'm switched to Desmos, and I've already typed this in, and I want us to take a look at this particular equation, all right? So here we go. Here's Desmos. It's in there. And what I want you to see are, where does this hit the x-axis? So again, once I get my equation typed in there, which it's typed in there, and I just tap on it, and I look at the values, I have -2, I have 1, and I have 3. So what I'm going to do real quick is go back to my paper, and I'm doing this right now, and I'm just going to draw this graph in there. And I'm going to mark those points. Okay, so again, I'm just putting this on my paper and you can see it in just a moment. And then I would suggest you pause your camera and write them all down. All right, so I'm going back and here comes the shape. So again, like I said, -2, 0, 1, 0, and 3, 0. So the idea is I should be able to factor this to figure out those zeros, because when we solve, we're seeing the zeros, we're seeing where it hits the x-axis, we're seeing where y is equal 0. So if I did try to factor this, because it said equal to 0, what numbers for x would make my y's 0, that's what all of these are, I would do that whole grouping method. And I would start again with the GCF, which is x squared. And when I'm done, I get x minus 2, which, as you remember, I have to do a GCF over here, but these have to match. This has to be x minus 2. So I'm just going to write an M for match. So I would ask myself, well, what neighbor would be hanging out here to multiply x to get to this? And it would be a -5. But if I really check this, I get -5x. But when I distribute to here, I don't get 6. I get 10. So as it turns out, this is not factorable. So how do we come up with the answers of -2, 1, and 3 without letting the graphing calculator do the work for us? Okay, so one thing I have to stress, when we take this test, you won't be using your graphing calculator for it. You can have a regular calculator, but not a graphing calculator. So let's take a look at this one. So in this example, I'm going to go ahead and tell you one of the X-intercepts. And so what we're going to do from there is I just want to prove to you is that once I give you a number, what happens? That, that we can get 0 out of it. So, and this all ties into stuff that pops up on your test. So I'm just going to put 5 in here. So again, whenever I do that, I always like to put the number in parentheses. And this is good just to remind you of some of the math that would take place. So since it's just a bunch of numbers, I would follow the order of operations and I would do 5 cubed first. I would do my exponents, and you can use a calculator. That's 125. I would do this exponent, which is 25. From there, I would do my multiplying, which is this. And I get 110. And then if I take and, just type this into my calculator, 125 plus 25 is 150. Take away 110, that's 40. Take away another 40, we get 0. Okay? So 2 big things are happening here. One is you won't be able to factor. And 2 is I'm going to give you a solution, something that would be across the x-axis, and you should get 0 out of that. All right? So let's go to the whole point of this lesson. What do you do when you can't factor? And there's this theorem, it's called the rational root theorem. And it just says that k, so some number is going to be a root, it's going to be a 0, it's going to be a place that crosses the x-axis. of your big function, and you know k is going to be possibly a number where it's called p over q. And it just means that you're going to take the factors of the number at the end, and you're going to take factors of the number at the beginning, and you're going to make a fraction. And what we're going to do is we're going to come up with this list of numbers. And in this list of numbers, 1, 2, 3, some of them, at least one of them, is going to be a 0. It's going to be a place that crosses the x-axis. So the first thing we need to know is, well, what is this list? So what I do is I take factors of the end, and you want to look at this as 10, negative 10. And if I just take factors of negative 10, you know, that's 1 and 10, and 2 and 5. And I always like to just put them in order. So this is a good idea to use that factor page or your factor program. But I have to realize that 2 times 5 wouldn't get me to 10, but I could also have some positive and negative numbers making that up, like negative 2 and negative 5. So I'm going to list them as positive, but I also have to realize that this whole list could be negative. I hope that makes sense. And I don't want to write 1, 2, 5, 10, negative 1, negative 2, negative 5, negative 10. So I kind of just put that plus or minus in front. So I look at the number at the end, and then I look at the number in the beginning, which is a 1, and I just take factors of 1, and I do put it in this order. And so to multiply to 1, I could do 1 times 1. I'm only going to write it once, but I could also do negative 1 times negative 1. So again, there's going to be this positive and negative 1. All right? So even though you only see 5 numbers here, there's actually technically 10. And what I'm going to do is I'm going to make a bunch of fractions. And this is going to be p. This is going to be the numerator, the one at the end. That's why I start at the end. And the number in front is q. It's just the denominator. And I'm going to make a bunch of fractions. So I could do 1 over 1, which is just 1, 2 over 1, which is 2, 5 over 1, which is 5, 10 over 1, which is 10. And then I would still have all the negative ones. So what if I really wanted to do is I could just rewrite them separately like this. Or I could just write them once, like this. It's really up to you. But if you see it like this, you think there's 4 possible choices. There's actually 8 possible choices. So for now, I'm just going to stick with this. And 1, 2, maybe 3 of these 8 numbers is going to be an answer. It's a number that if I put it into here, I'd get 0. And one of these numbers is going to help me factor this. All right, so let's just take a quick look and see. I'm going to use the graphing calculator here, which one it could possibly be. So I'm going to type in the equation real quick. So hold on. Okay, and so here it comes. All right, so this is the shape, and I don't know how well you can see that, but that's actually 2. All right, and just trust me, it's 2. I'm not going to check it out. So as it turns out, in this list of numbers, 2, if I did the same thing up here and put it in here, I would get 0 at the end. And then 2 will help me factor this. All right, so 2 big parts there. So let's take a look. What we're going to do is we're going to solve this problem. And the first thing I want you to notice is it has way more than 4. This has 5. So what's going to happen is I've not taught you how to factor with 5. So automatically, sorry, you're already screwed. So you can't do that whole grouping method because there's an odd amount. So what we're going to do is we're going to come up with a list of numbers. And I'm going to show you this process that's called, well, it's called synthetic division. You just kind of have to understand how I do this. So what I'm going to do is go to the end, take factors of 8, and remember, when I do this, I always want to make a positive and negative set of factors. So I like to put them in order. And then I'm going to go to the front and take factors of 2. Again, always make a positive and negative set. And then I'm going to make a list of fractions. And this is the numerator, and these are the denominator. So first I'll just start with 1 over 1, 2 over 1, 4 over 1, and 8 over 1, which is just 1, 2, 4, and 8. But now I'm going to make another set of fractions, and it'll be 1 over 2, so I'll have a half, 2 over 2, which is just 1. I don't need to rewrite it. 4 over 2, which is 2, and 8 over 2, which is 8. And even though it looks like there's 5 numbers there, remember there's a positive and negative version of all of these. So you can write out the negative versions, or you can just do this. So again, there's not 5 numbers here, there are 10 numbers here. So as it turns out, one of the numbers that will work is usually 1 or negative 1, all right? And we're just going to test this out. So give me 1 second. I am going to pause the video real quick. All right, so what I'm going to show you, you've not seen this before. This is one of the things in first semester I kind of had to decide, do I show it now or do I show it later? So we will be practicing this technique when we see each other in class. So what I'm going to do is, in first semester we learned about adding, subtracting, multiplying with polynomials, and the one I left out was division, not the division I should have showed you. So what's going to happen here is I'm going to make this upside down bar, and I want you to think of this as a reversed division box. And what I'm going to do is check every number in this list, and I'm going to make sure that I have all the powers after 4. So think of it as a countdown. 4, 3, 2, this is like a first power, and then there's no power. If I have that, I am good to go. So what I'm going to do is put a 2. I'm going to put a negative 5. I'll put 10. I'll put negative 20. And I'll put 8. Okay? So, and the video from Monday would have shown you all of this. So just keep this in mind. This shouldn't look too new to you because this would have been Monday's video. Anyway, the numbers I want to test, these numbers go on the outside, all right? Sorry, these numbers go on the outside. I was looking in the wrong spot. So I want to test 1, I want to test negative 1, 2, 4, negative 4, 8. Usually 1 or negative 1 works. So I'm going to show you a number that doesn't work because I've already checked. And then I'm going to show you the number that does work. And then you're going to know how it works or if it doesn't work, okay? So I'm going to test 1 because 1 and negative 1 usually work. And so what I do is I just put the 1 out here. This shouldn't look familiar. This was Monday's video. And the first thing I do is I bring this 2 down. And now that I'm saying Monday's video, I have to remember that we actually weren't in school on Monday, so we'll be doing that live. Never mind. So anyway, I'm going to bring the 2 down. And what I do now is I'm going to multiply. I take 1 times 2 is 2, and I put it here. And you just have to be able to add and subtract. And I'm going to add this column, and I'm going to get a negative 3. And then I'm going to multiply again. 1 with negative 3, that's negative 3. And I'm going to add this column up, and I get 7. And then I'm going to take 1 times 7, which is 7, put it here. And when I add those up, I get negative 13. And then when I do 1 times negative 13, which is negative 13, add those up, and I get negative 5. So as it turns out, this is just never going to work. I can't. So what I want to have happen is I want to get 0 out of this. So based on, and I take it back, I am going to make a little previous video. This means if I put 1 in here and I did the math, I would get negative 5. And what I want to have is to be able to put 1 in here and get 0, okay? So I don't like that I got negative 5. I have to get 0 at the end. So as it turns out, 1 doesn't work. So what I'm going to do now is switch to a number that I already know does work. So as it turns out in this list, I know that 2 works. So I'm going to write this much smaller here. And again, I'm just going to rewrite these numbers here. 2, negative 5, 10, negative 20, and 8. And I'm going to start by bringing this number down, 2, and now I'm going to multiply. 2 times 2 is 4. And then I'm going to add this column up and get negative 1. And 2 times negative 1 is negative 2. I'm going to add this up and get 8. 2 times 8 is 16. Add this up and I get negative 4. And multiply those and I get negative 8. And as it turns out, I get 0. So normally, again, I could put 2 in here like I did here and get 0. But what I need are these numbers down here. So that's why we're not doing it the other way. We're doing it this way. So first of all, I already know one of my zeros, just to point out. So one of my zeros. it's going to be 2. X is 2. All right? And so what I'll be doing is kind of making a list of zeros and factors here in just a moment. And now what I'm going to do is I want you to think of this. This is some form of division. This is your remainder. And this is called the constant. And this is an x. And I get an x squared. And I get an x cubed. Basically, I'm making this out of standard form. And again, the last is always 0. And then you get just a number, you get x squared, you get x cubed, you get x fourth, and I'm just building that up. So what I'm going to do is rewrite that over here. And so I'm going to write 2x cubed minus 1x squared plus 8x minus 4. And now we just took something that wasn't factorable, did a little bit of work, and now I should have something that's factorable. So what I do first is I'm going to try to factor this now, because that didn't work. So this is my quadratic formula for this chapter. I would look for a GCF, which I don't see one. And since there are 4 terms, I'm going to group these. Okay? And the first thing I'm going to do is take an x squared out. And when I do that, I'll be left with 2x and minus 1. And again, now I'm going to make that matching set, which will be 2x minus 1. And then what would I have to take out of this to make this? What would that GCF be? It would be a 4. And so now what I'm doing is I'm working on finding the other zeros. One factor is the matching set, 2x minus 1. The other one are the things on the outside, so x squared plus 4. And now I'm just going to set each factor equal to 0 and solve. So for this one, I'd start by adding 1 and dividing by 2, and I get a half. For this one, I'd subtract 4, and so remember, I'll be taking the square root of a negative number, so I will get 2 answers because of the square root, but it'll be 2i. So according to this, all of my zeros, I figured out 1 through this process over here. I've got another factor, x equals 1/2. I've got this factor, or solution, and I'll write it twice. And let's just remember, according to this, I was supposed to have 4 answers, and I do, 1, 2, 3, 4. And I want you to realize all the factors that made this up, okay? So over here, I'm going to write the factors. So the factor that gave me 1/2 was this 2x minus 1. And this is going to have to be written small. The factor that gave me 2i and negative 2i is just this x squared plus 4. But then, what factor would have given me this? As it turns out, I could figure that out. It would have been an x minus 2. So now I've done a lot of different things here. One, I found out where my graph, all the areas where it's going to equal 0, or my 4 answers. But I also got it from standard form into factored form right up here. So 2x minus 1, x minus 2, and x squared plus 4. And later what we're going to do is we're going to be graphing this, okay? So I think I've said a lot of things that haven't made sense, hopefully not math-wise, but I wasn't thinking about what week this video was in and that we didn't have Monday. So let's finish this. All right, my goal is to find the x-intercepts to solve, which means I would set it equal to 0. And if I try to factor, I'm just going to use a pencil here real quick because it won't work. 4 terms, there's not a GCF, but I would take out an x squared and I would get x plus 7, which when I get over here, I need my matching x plus 7. And there's no way I can get x plus 7 from this. So as it turns out, it's not factorable. So I'm going to erase, well, I'll just write not factorable. This is me proving it's not factorable. So now what I have to do is I need a little help so I can get it factorable. So I do what's called the rational root theorem. So I take factors of negative 40. So plus or minus, I hope I get these all, 4, 5, 8, 10, 20, ooh, I'm going to run out of room, and 40. And then I take factors of the front number, which is 1, which is great, because the only factors of 1 are 1. And then again, this is the numerator, this is the denominator. And as soon as I put these over 1, I just get positive and negative 1, 2, 4, 5, 8, 10, and 20. So these are the numbers I would want to test. Again, usually 1 and -1 work. I'm going to do a quick check and see. All right, so first I'm going to pick one that I know is not going to work, and then I'm going to give you the one that does work. All right? All right, so what's not going to work? Well, 1, as it turns out, is not going to work. So again, the numbers that I put in here, I look here, I want to make sure it's in standard form, and then I have a countdown of the exponents. 3, 2, a first exponent, no exponent, and I write those numbers down. Ooh, forgot my 7. Okay, and I always bring the first number down, and now I multiply, I add, I multiply, I add, I multiply, I add, and I need to get 0, and I got -30, so 1 doesn't work. All right, so what is the number that's going to work? As it turns out, 2 is going to work. So I'm going to recopy those numbers, and I'm going to bring the 1 down again, and now when I multiply, I get 2, add, multiply, add, multiply, add, and I get 0. So again, I want you to think we don't need this number, but this number is going to be the constant. It does not get an x, so I'll just put a c there. This gets an x, and this would get an x squared. And now we're going to take this, and we should have something that's factorable. So as I do this, I'm going to put my zeros here, and I will list my final factors here. Okay? So I have one of the zeros. If x is 2 and I do the math, I get 0. If I put 2 in here and done that, I would have gotten 0. Okay? So 1, 0 is 2, and we'll write the factor later. So what I'm going to do right now is take this, and I'm going to factor it. And I look for my GCF. I don't see one. And now I'm going to look for, since there's 3 terms, I'm going to make my x. So I need factors of 20 that get me to 9, and that's a 5x and a 4x. And then I can go to my factors or my neighbors, and x and x make the x squared. And then x times to get to here could be a positive 5. And x times what could get me to there would be a 4. And now if I just set each factor equal to 0, I get my answers. So now, remember, there were supposed to be 3 answers to this problem. So we found one, this crazy irrational root theorem way, and now I've got 2 more. So I've got -4, and I've got 5, and I know the factor that got me here, x plus 5. I know the factor that got me here, x plus 4, and it's pretty easy to get this factor. That would be x minus 2. So again, I just went from standard form to factored form. I found the zeros. I know all the numbers that if I put it in here would make my y become 0. So other numbers that would have worked here, if I'd put -4, I would have gotten 0, and if I'd put 5, I would have gotten 0. And all the other numbers, I wouldn't have gotten 0. All right, this time, we're going to let the calculator assist us. All right, so what I would like for you to do is you can use your graphing calculator here. You can also go to Desmos. It does not matter. And I'm typing this in. And I'll tell you how we're going to use the calculator. So if you want to see what this looks like, you're more than welcome to, but I don't really care what it looks like. I want to know where do I get y values, okay? So in this time, we are not going to make the list because we're going to let the calculator help us. And the only thing you need is the table. And I want to look to see, are there any x values here that give me 0? And I'm not seeing any, so let me pause and make sure I typed it in correctly. All right, after looking at the problem, I don't like this problem. Again, I borrowed these notes. Sorry, I should have checked ahead of time. We're going to change it into y equals x cubed minus 6x squared plus 11x minus 6. So first, again, finding the zeros. What I would try, because it's so much faster, is I would try to factor this. So let me just show you why it doesn't work. So again, I take a GCF, there's not a GCF for the whole thing, but for the first set of parentheses, I could take an x squared out and get x minus 6. And when I go for my matching, there's nothing I can take out of this to make x minus 6. So it's not factorable. And so now what I should do is make that list of numbers. I should take factors of 6, negative 6, and put them over factors of 1 and get that list of numbers. This time we're going to use the calculator to assist us. And the only thing I really want to look at, I'm going to go ahead and look at the shape. So I've typed it into the graphing calculator. It just takes a moment. I can see some nice points where it's graphing. I'm just going to go to the table and see what x values would have gotten my y to be 0. So I've got a lot of numbers to choose from, 1, 2, or 3. So I just need to pick one of those and then go from there. So as I said, 1 usually works, and this is the first time it's working, so I'm going to put it here. And again, I need to make sure I have my countdown of x's, 3, 2, 1, 0. So I've got 1, I've got negative 6, I've got 11, and I've got a negative 6. And you always bring that first number down. 1 times 1 is 1. I'm going to add those up. 1 times negative 5 is negative 5. Add those up. 1 times 6 is 6. Add those up, and we do get 0. Remember, the last number we don't need. This is going to be called our constant. This will get an x, and this will get an x squared. Again, we want 1. If I'd put 1 in here, I would have gotten 0. But it's these numbers that I need, so that's why we're doing this a different way. So again, I'm going to write my factors here, and I'll put the zeros on the other side. So I already got 1, 0. It's 1. And remember, I'm supposed to have 3 answers. So I'm going to take this now, x squared minus 5x plus 6. I'm going to make my x for factoring. And when I do that, factors of 6 that get me to negative 5, you got to be careful because 1 and 6 get me here, and so do 2 and 3. But I'm going to have to choose 2 and 3 and make them both negative. So when I multiply these, I get the positive 6, and when I add them, I get the negative 5. And so now I can factor. Here are my factors, or my neighbors. X and x make x squared. And I draw the loops, so I can do x with a negative 2 to get to here. And I can do x with a negative 3 to get to here. And so once I set these equal to 0, I can get my answers. So joining my zeros are 2 and 3. Their factors are x minus 2 and x minus 3. And this factor would just be x minus 1. So all the things I've done. 1, I found all the numbers that make this 0. Which means I found all the numbers where it hits the x-axis. It'll hit the x-axis at 1, 2, and 3. The other thing I've done is I put it into factored form. X minus 1, x minus 2, whoops, you can't see that, and x minus 3. So I apologize if you were gone and you had to watch this video, but hopefully this makes a little bit more sense.